Hey guys, welcome to my humble abode. You're going to be hearing this lecture on how to do the lab assignment from my home because I canceled class today due to the snow. So thank you for watching this video. I know it's a little bit of a different format than you're used to, but I anticipate I'll be able to provide you with enough guidance to help you complete the lab assignment on your own before Sunday when it's due. So on our Moodle page, if you look at today's date, February 21st, and scroll down at 2 p.m. today, you'll be able to download the lab assignment document, which is about z-tests. And then also at 2 o'clock, the submission link will open so that you can upload your completed lab assignment once it's done. I'm going to show you what the lab assignment looks like. So we're going to be doing z-tests, and you're going to be doing the same thing across 3 examples. So I'm going to do the first example with you, which is about the slap chop. Maybe some of you have this device. And then at home on your own, you're going to be doing the same set of operations for the Snuggie and then again for the Sham Wow. And that's it for this lab assignment. So as far as missing class goes due to snow, this is a great day to miss because it's relatively an easy lab assignment. Okay, so I'm going to go through the first example of the lab assignment on PowerPoint here. So these are the instructions. And if you haven't done so already, please open up this lab document on your computer as you're watching me and follow along. So the instructions, as you can see, are that now that your statistical skills have become a bit more sophisticated, you vow never to succumb to infomercials aired in the wee hours of the morning. Instead, you decide to analyze the claims laid out by some infomercials to determine how effective their products actually are. After some digging on the product websites, you uncover statistics about the effectiveness of each product. Now all you need to figure out is whether their findings are all that significant, as in statistically significant. Okay, so the first product, the first infomercial product we're going to be talking about is the Slap Chop. The makers of Slap Chop claim that their product is more efficient at chopping vegetables than a knife. They have population data that indicates the average amount of time it takes to chop an onion by hand with a knife is 2 minutes and 40 seconds, or 2.40 minutes, I should say, with a standard deviation of 3. They conducted a study on a random sample of 150 adults and found that it only took an average of 1.82 minutes to chop an onion using the Slap Chop, which they claim proves its superiority. So here we have a difference between means, right? 1.82 for the Slap Chop and 2.40 for the knife, doing it by hand. The question is this difference between means the result of chance, dumb luck, or does it reflect some real-world effect? Does it truly reflect the Slap Chop being more effective than the knife? To answer this question, we have to use a two-tailed hypothesis test with an alpha level of 0.05 and draw some conclusions about their data. So from the lectures that you watched this week, you know that there are 5 steps to hypothesis testing. And the first step is to state your hypotheses. And you have your alternative hypothesis, which is your research hypothesis, the hypothesis that you think and hope will be correct. And then there's the null hypothesis, the one that says your research hypothesis is wrong. And then for each of those 2 types of hypotheses, you have to write out your hypothesis in 2 ways. You have to write it out descriptively in words and analytically in numbers in a mathematical formula. So I always find it easier to start with the alternative hypothesis. So what are the makers of Slap Chop claiming here? They're claiming that the Slap Chop is faster than cutting an onion by hand. That's their research hypothesis. That's the alternative hypothesis, and here I've phrased it in descriptive terms, in words. The Slap Chop is faster than cutting an onion by hand. Now I need to put this descriptive hypothesis into analytical format. So how does this look mathematically? It looks like this, where we've got H sub 1, which represents the alternative hypothesis or the research hypothesis, and we have the mean, that's what the mu represents, the mean of the Slap Chop being less than 2.40. Remember, 2.40 is the amount of time it takes to cut an onion by hand, And the makers of Slapchop are saying it takes less time than that. So if this hypothesis is correct, then the mean for Slapchop will be less than 2.40 minutes. Now let's do the null hypothesis. Remember from lecture that these two hypotheses have to be mutually exclusive. So we have to phrase the null hypothesis in such a way that the world falls into one of two states. Either the alternative hypothesis is correct or the null hypothesis is correct. But one of them will be correct and the other one has to be wrong. So the way to phrase this to be mutually exclusive is to say the Slapchop is not faster than cutting an onion by hand. Notice these are mutually exclusive. Either the Slapchop will be faster or it will not be faster. There's no other way that the world could fall. It's going to be in one of these two states of affairs. So the Slapchop is not faster than cutting an onion by hand is the null hypothesis written out in descriptive terms. And when we do the null hypothesis in analytical terms, we see H sub O, H sub 0, and the 0 represents null here. So this is the null hypothesis, where the mean of Slapchops is greater than or equal to 2.40. Those are the two ways that the alternative hypothesis could be wrong, right? The alternative hypothesis is that the Slapchop will be faster. One way that could be wrong is if the Slapchop is slower, right? So if the mean of Slapchop is greater than 2.40 seconds or minutes, if it takes longer than 2.40 minutes, then it's not faster. Or if it's equal to the amount of time it takes to cut an onion by hand using a knife. That is another way in which the Slapchop would not be faster than cutting an onion by hand. So we have less than down here and greater than or equal to up here. The world has to fall into one of these two states. They can't both be right or both be wrong. It's going to be one or the other. So those are our two hypotheses. Let's move on to the second question. The second question is to determine the criterion. What is the z-crit? What is the critical value for the z-score that would allow us to reject the null hypothesis, that would allow us to say these results are too unlikely to have been obtained by chance alone, so they probably weren't obtained by chance alone. They probably reflect some real-world event. Remember, this is a two-tailed test. I said that right here in the instructions, using a two-tailed hypothesis test. So even though we're making a directional prediction, we're predicting that the Slapchop will be faster than cutting an onion by hand, which is directional. We're going to use a two-tailed test where our alpha level of 0.05, which again I specified right here, where that 5% of the distribution is split across two tails rather than being all in one tail. So when you cut 5% in half, you get 2.5% in the left tail and 2.5% in the right tail. And so in each tail, we're looking for the critical value associated with 0.025. We find those critical values in the unit normal table. In your book, this is Appendix B, I believe. And if you're looking at the unit normal table with the handout from Moodle instead of looking in the back of your book, the row we're looking for here is on the third page. Here we're looking for the tail, which is the middle column. Okay, we're looking in the tail to find 0.025. So 0.025 is right here. 0.025, that's how much is in each tail. And the z-score associated with 0.025 in the tails is 1.96. So the z-score we calculate has to be equal to or greater than 1.96 in order for us to reject the null hypothesis and say that we found a statistically significant difference. So the criterion, the z-crit, is 1.96, and that's when there's 0.025% of the distribution in each tail. Now we have to conduct our hypothesis test. So that involves calculating the z-score and comparing it to the critical value, which on the previous slide was 1.96. So is the z-score we calculate equal to or greater than this threshold? That's what we're going to do first. Now, to refresh your memory, in lecture, a couple of lectures back, it was before the last exam you took, we have the formula for z-scores for sample means. And take a moment now and find this formula on your formula sheet. You should know where it is because you had to reference it when you were completing the exam. I believe it's in the bottom left. So here you've got the z-score for sample means, where you take the sample mean, subtract that from the population mean, and then divide that by the standard error, which is the standard deviation of a distribution of sample means. And then in that lecture, I walked you through an example. This is a screenshot of that example where we took the mean, this was for a group of presidents, subtracted from that the population average for all presidents' age. And then in the denominator, we had to figure out the standard error of the mean. This is the formula for the standard error of the mean. Again, pause, find the formula for standard error of the mean in your formula sheet. It's right next to this formula in the bottom left, I believe. So we use this formula where the numerator represents the population standard deviation, which in this example was 6.32. And then you divide that by the square root of the sample size, which in this example was 5. When you crunch all those numbers out, you get a standard error of 2.83. So that's what goes in the denominator. And in the numerator, we have the difference score here. And when you divide 3.4 by 2.83, you get a z-score of 1.20, which tells you that this particular sample mean of 58 is 1 standard deviation and 20% of a second standard deviation. So 1 and 20% of another standard deviation above the population mean. So this formula that we're going to calculate tells us how far the sample mean is from the population mean, how far the slap chop mean is from the mean of cutting an onion by hand using a knife in standard deviation units. Okay, so let's do that. So here's the formula again, same formula you saw on the previous slide, sample mean minus population mean over standard error. And here's the formula for standard error, where we have the population standard deviation divided by the square root of the sample size. In this example with the slap chop, the standard deviation is 3. If we go backwards, you'll see where I say that right here, the population standard deviation is 3. In a moment, I'm going to ask for the population mean, which is 240. I'm going to ask for the sample mean, which is 1.82, and the sample size, which is 150. All of that information is right here in the question. Okay, so to figure out the standard error, we have the population standard deviation, which is 3 in the numerator. Then we have the square root of the sample size, which was 150 in the denominator. When you crunch this out, you get a standard error of 0.24, so that's what goes in the denominator down here. In the numerator, we have the sample mean, which is how long it takes to cut an onion using a slap chop, which is 1.82, minus the population mean, which is how long it takes to cut an onion by hand using a knife, which is 2.4. And when you crunch that out, you get a z-score of negative 2.42. And again, you can avoid or you can ignore the negative here. It would have been positive if we had the population mean first and the sample mean second. That's totally arbitrary. It's 2.42. So now we have to compare the z-score we obtained, the z-score we worked for, right, the one we calculated, to the z-score critical value, the z-crit. We determined from the unit normal table that the z-crit was 1.96. Is 2.42 more extreme, i.e. closer to the tails, than 1.96? It is. So because it passed that threshold, because it is more extreme than that threshold we set, our results are statistically significant, and we should draw the conclusion to reject the null hypothesis. And if we go back, the null hypothesis was that the slap chop is not faster than cutting an onion by hand. We are rejecting that. That is not the correct one, probabilistically speaking, meaning the correct one is the alternative hypothesis, that the slap chop is faster than cutting an onion by hand. And in a moment, the next part of the question is going to ask you to phrase these results in APA style. I simply take the hypothesis that was supported and make that my phrasing for my APA style results. So the hypothesis that was supported is this one. The slap chop is faster than cutting an onion by hand. As you'll see in a moment, that's how I'm going to phrase my results. Okay, so yes. So the next thing this question asks is write your results in APA style. Recall from the lectures this week that you have to describe your results in everyday language, include whatever descriptive statistics you have, like the mean and standard deviation, then include your inferential stat, your test statistic, and the p-value. So we're going to do exactly that. So here is the results in descriptive format. It takes less time to cut an onion using the slap chop than a knife. If you look back to the alternative hypothesis, this is phrased very similarly to how the alternative hypothesis is phrased, and that's great. There's nothing wrong with doing that. I also inserted some descriptive statistics here. This is the average time it takes to cut an onion using the slap chop. This is the average time it takes to cut an onion using a knife. I did have information about the standard deviation for the knife. I did not for the slap chop, so I included standard deviation info for the knife, but I couldn't for the slap chop. So I've described the results in everyday language. I included my descriptive stats. Now I have to report my z-score. So the z we obtained, not the z-crit, but the z that we calculated, the one we worked for, is the one you report. The z we got was negative 2.42, so that's what I wrote down here. And the p-value is less than 0.05. That's what happens when you cross that threshold, when your obtained statistic surpasses the critical value, which was the case here. 2.42 is more extreme than 1.96. That means the odds of receiving this result by chance are less than 5%. And that's what we're communicating here. The probability, that's what P stands for, is less than 5%. So those are the results written out in APA style right here. Now sometimes, especially when you're reporting something in a paper for publication, the journal editors and reviewers and the readership will prefer an exact p-value rather than a p-value that just says greater than or less than 0.05. They want to know what is the exact probability of getting the results you got by dumb luck alone. So when we get to the next question, we're going to address that issue. So the next question, the last question, asks to use the unit normal table to determine the exact probability of obtaining the z-score we got in question 3. This one, what is the exact probability of getting a z-score that extreme or higher? If the slap chop is actually not more efficient than a knife, so if the null hypothesis is true, how unusual would it be to get a z-score that extreme or more extreme? So to answer this question, we again have to look at the unit normal table as indicated in the question. And now we know the z-score, which was 2.42. And so we find that z-score here. This is again on the third page of the handout if you're using the handout. 2.42 is right here. And we're looking in the tails. And as you can see, 0.0078. So if we move that decimal over 2 spots, there is 78% of 1% of a chance, or 78th of 1% of a chance of getting these results by dumb luck alone. In other words, less than 1% of the time will you get results this extreme by dumb luck alone. That is really infrequent. That is a really extreme z-score that is unlikely to have been obtained by chance. So this is what we're going to report in the answer, 0.0078. Right, or 0.78%, no, not even 1%, right? It's 78% of 1%. So that is the exact probability of getting a z-score of 2.42. And then I ask, is the conclusion we drew based on the exact probability, the conclusion meaning to reject the null hypothesis or retain the null hypothesis, is the conclusion we draw based on this exact probability the same conclusion we drew based on our hypothesis test of it being greater than or less than 0.05 based on whether it crossed that threshold or not? So if we go back, you can see that we drew the conclusion to reject the null hypothesis because our obtained z surpassed the critical value to reject the null hypothesis, is that the same conclusion we would draw now? Is this exact p-value less than 5%? If it is, then we would draw the same conclusion to reject the null hypothesis. And yes, 0.78% is much less than 5%. So this result is consistent with our hypothesis test. Both are communicating that it is extremely unlikely to get this result by chance alone, to get a z value of 2.42 by chance alone if the slap chop is truly not more efficient than a knife, if there really is no difference between these two things. So that is the sequence of operations that you're going to perform for the next two examples, the Snuggie and the ShamWow. You're going to be doing the exact same thing, just with different numbers. So I hope that this provided you with a pretty good template for how to move forward and complete the rest of the lab assignment yourself. Now that we're done with that demonstration, I just want to talk to you about the peer review the IM draft that you turned in today for the peer review that will be due next week. So today, which is the 21st, you had to submit your IM draft for peer review. And notice, this is one occasion in which late submissions will not be accepted. So you have to turn in a complete IM draft, not just like a paragraph or two from your introduction section and you'll figure out the rest later, right? Complete introduction, complete method section, and it has to be submitted on time, because today or tonight, I'm going to take your IM paper, remove your name and email and any identifying information, and then send it to another student in class who's going to complete a peer review on your paper. And I want to make sure that that student has an entire week with your paper to complete the peer review assignment. Likewise, you're going to be receiving an anonymous IM paper from another student in class, and I want you to have a full week to review their paper. So that's why this IM draft has to be complete and submitted on time. I'm actually not going to be looking at these IM drafts at all. I'm only going to be looking at the title page to just take your name off, put your V number in instead, and change your email. I'm not going to be reading any of the content. So if you're not super proud of it quite yet, that's okay. I'm not going to see it. Then next week, you can see that your peer review is due. So let's go over the instructions for the peer review assignment. Okay, so here they are right here, and you can find these instructions at the top of our Moodle page under Research Report Materials and then the Peer Review folder. Scroll back down. Okay. So for this assignment, it's worth 30 points, which is a pretty big chunk of your grade, relatively speaking. You're going to act as an anonymous peer reviewer for a fellow student. And this is a process that we researchers do in the real world all the time. On a monthly basis, journal editors contact me asking me to review a submission, the paper that somebody has submitted to their journal, to provide feedback on it about whether its quality is high enough to get into the journal, what revisions need to be made in order to get into the journal, etc. And so we're going to try and replicate this process in our class. Your instructions are to read the paper you receive diligently, carefully, critically evaluate each sentence. Is the meaning of the sentence clear, right? So you really have to have a fine-tooth comb when you're looking through these IM papers. Don't just read a whole paragraph and then try to see if you understood the gist of the paragraph. Stop after each sentence and ask yourself, did that sentence communicate something meaningful and clearly? So does it contribute a meaningful piece of information, or is it just filler or fluff? You guys know I hate fluffy sentences that are just adding length without communicating anything. So if you see something that's fluffy, call them on it kindly. Then you're going to write comments and edits and suggestions directly on their paper. Remember that helpful comments are specific, and also remember to be kind, but critical when necessary. So be specific. Don't just say, this is awkward, or I don't like this sentence, or this is unclear. Try to be as specific as you can, and, be like constructive criticism, right? Where you're kind, but don't hesitate to be critical, because that's ultimately going to be in the student's best interest for you to catch some errors. Keep your eyes open for typos and APA errors. So whenever you are reviewing the student's paper, you can use something called track changes, which is what I use when I'm grading your research reports. Here I've got on our Moodle page a link to a YouTube video on how to use track changes. I'm going to show you right now too. One thing to notice though is that, well, I'll show you in a minute. So when you're in Word, imagine this is the student's paper that you received. If you go to Review and then Tracking, you can turn track changes on. Then anything you do to their paper will be noted in the sidebar. So you can delete things, you can add things, and the added portions will be indicated in red. You can also make comments, right? So if this sentence is unclear, you can say new comment. I have no idea what you mean by the KKJDF, whatever, right? So you can add comments too. But the caution I have here is if you use track changes, make sure your name is not shown in the comment bubbles. So because this license of Word or Microsoft Office is, to me, my name is in the bubbles. So if you don't mind the student knowing who reviewed their paper, you can keep your name in there. But if you would rather it be anonymous, then I believe there's a way to change the settings so that you remove your name as the license owner, which is kind of onerous to do. You could instead do it on a campus computer, and then you wouldn't have your name in the bubbles. So if you don't mind your name being on there, it's fine. But if you do want to remain anonymous, as most people do, then you're gonna have to find some way around your name being in those bubbles. Okay, so you're going to make edits and suggestions and comments directly in their paper using track changes, and you're going to answer these questions below. And you can respond to the questions in a new document, or you can use this exact document, the peer review guidelines document, and just start typing your answers in that document. Either way. Your grade, the 30 points that you could get, will in large part be determined by the amount of effort and the thoughtfulness you put into your review. Writing a good, helpful review takes a lot of time, so don't rush it. Again, you're evaluating each sentence one at a time. Your colleague is counting on you to make high-quality comments and suggestions, so please do your best to provide meaningful edits to their paper that are correct, right, that won't lead them astray. To help improve their paper. And just as an FYI, the feedback that you get from another student in class, you don't have to take it. There have been plenty of occasions when I've seen reviewers give misleading information, telling students, hey, you wrote this wrong, you should write it that way, but the reviewer was actually wrong. The student had it correct to begin with. So use your own best judgment when deciding which of the reviewer's comments and edits to accept and which to reject. So these are the questions you're going to have to answer. There's 16 of them. You can see they're broken down by the different sections of the paper. And then the grade sheet, this is what I'm going to get from you guys, right? Your answers to these questions about their paper, and I'm going to grade your answers using this grade sheet. So these are the questions. I just copy and pasted them again, all 16 of them, and I'm going to give you a 0, 1, or 2 points for each one of these questions depending upon how thoroughly you answered them. So that's how it's going to add up to 30 points. In case you're curious, the last one here is kind of optional. So if you don't include that one, there's 15 questions with a maximum of 2 points each to get 30 points for this assignment. So that's it. So that's what you guys should be working on. In addition to preparing for lecture next week, you should be working on reviewing your peers' IM draft and providing them feedback. That feedback is due a week from today on Wednesday, the 28th. You're going to upload that feedback to Moodle right here. Not going to send it to the student themselves. You're going to give it to me. Then I'm going to wipe your name as best as I can. I won't be able to wipe it from the comments, unfortunately, but I'm going to try to make you anonymous, and then I will send it back to the student. So you don't have to worry about it getting back to them. You just get it to me. So that's it. That's the lab assignment. That's the research report that's due next. And as I mentioned in my email, I'm just going to give you guys 10 points for the quiz that we would have had in class today. I recommend not making that one of the quizzes you drop. You don't actually have to tell me which one you're going to drop. Moodle will automatically figure out which is the lowest and drop that for you. Okay, I'm out of breath. That's it. I will see you guys in class on Wednesday. And if you have any questions about the lecture material, the lab assignment, the research report, anything, between now and then, please stop by the TA's office hours or my office hours. All right, catch you guys later. Bye.